So single-step equations are when we solve equations with one step. So it's really important to understand when you have an equation that you can solve versus having an expression that you can't solve. So for example, here a plus 3 minus 4, that's an expression you just can't solve. You can simplify this, you can combine like terms, but you can't actually solve it. Here you have an equation, a plus 3 equals. Okay, because it's an equals, that kind of gives you an indication that this is an equation and you might be able to solve for a, and in this case, we can solve for a. So lastly, we were just dealing with equation inequality. So the golden rule with equations is whatever you do to one side, you do the same to the other. You must keep it balanced. You can do whatever you want to equations as long as you keep it balanced. Now, the goal though now, and this is a little bit different from last day now, the goal is we now want to solve for the unknown, solve for that variable. And we do this by undoing calculations. So we know that some number plus 5 equals 7. So we want to do the opposite or undo 5 or do the inverse of 5, which is minus. So here if I want to undo the 5, I can just do minus 5. So I've undone the calculation. But the problem is if I undo it on the left side, I have to keep it balanced. And I have to do minus 5 on the right hand side. And when I do that, I can work out the left side and right side. And again, remember that here's our balanced line. As long as I keep it balanced, I can do whatever I want. Here I've kept it balanced, and by keeping it balanced, I've got a by itself, and I solve for a. So I get a is equal to 2. Here, I want to undo the minus 5. So I know some number minus 5 equals 7. So I want to do the opposite or undo it. So I'm going to undo the plus 5. And if I undo on one side of the equation, remember that it has to be the same on this side. So I have to do the same. So a plus 5 on this side. Okay, so this is my zero pair here. And I'm just left with a on one side and 12 on the other side. Okay, so we're going to add both sides to get rid of the subtraction. So try this one. What would we do to undo the minus 12? Okay, so we're going to do this, undo this by a plus 12. And again, we have this equation. We need to do the same on both sides. So I need to do a plus 12 on this side. There's my zero pair. So I end up with a is going to balance or equal to 15. So here I have 2a's equal 10. So what I can do is I can undo this times 2 with a divide by 2. Okay, as long as I divide by 2 on both sides, I keep it all balanced, and I end up with 1a on the left hand side. On the right hand side it becomes just 5. So here, divide by 5, we can undo that with a times 5. So I need to times 5 on this side. Okay, so we're undoing that divide with the times. So these cancel out. I'm just left with 1a. Okay, so when I have undo multiplication, I'm left with 1. Here I'm going to multiply, and I'm going to end up with a equals negative 30. Now we can check this by just substituting back in. So negative 30 divided by 5 equals negative 6. That all works. This must be correct. So we can always check our solutions by substituting back in. Okay, so to do this one, how do you undo? And is this a minus 3 or times by negative 3? That's the first thing you need to decide. Okay, is that a minus or a negative? Okay, so this is a negative because there's nothing on this side here that we're subtracting from. So it's a negative. So this is a times by negative 3. So I need to divide by negative 3. Here I'm going to divide by negative 3. So I end up with negative 3 divided by negative 3 cancels out. Positive divided by negative ends up being a negative answer. 12 divided by 3 is equal to 4. So the answer is negative 4. So if I plug it back in, Negative 3 times negative 4 equals positive 12. Check, that works when I substitute it back in.